Hi, you're welcome to Sir Henry's class, a channel where we make learning so easy and absorbable. If this is your first time of watching our video, consider liking, sharing, subscribing, recommend the channel also to your colleagues. So today we are going to do computing, and we are going to look at how to convert between data types, that is decimal into binary data type. So when we talk about decimal data type or binary numeral or data type, what do we mean? Let us look at what they entail and how we can convert them. So the objectives: by the end of this lesson, you would understand decimal, binary and hexadecimal numeral system. You would also be able to convert decimal numeral into binary numeral. And then you convert binary numeral back to decimal numeral. Alright, so decimal and binary system. Now this topic is under the concept of programming. So we all know programming is part of the lessons that are being treated in computing in JHS. So every computer is believed to have a language which we call the binary language. That is the language of the ones and zero. Now every computer is able to read the data that it receives in various forms. Some read the data in the form of integer. And we all know what integers are: numbers that are either positive or what negative. Some also read data type called float. Some read data type called char, char. Some read data type called string, character, and so on and so forth. So as a computer programmer, when you say a computer programmer, it is a person or an individual who creates or designs software or program to be used by the computer. So every programmer has its understanding of the numbers system that are used in computing. Same way as the computer. So we said the computer uses the language called binary language. So this binary language is the basic form of language the computer understands. So any information given to the computer is broken down into the binary language. Now, a computer programmer can read numbers in three forms. But when we talk about the computer, its main language is the binary language. So we have what we call the decimal system, which is also called the base 10 system. We'll look at it briefly. We have what we call the binary system, which is also called the base 2 number system. The base 2 number system. And then we have the third one, which is the hexadecimal number system, which is also base 16. So as a programmer, you can read your numbers in these three forms, but the computer understands this binary system. So whatever information given to the computer is going to break it down to the binary. But as a programmer, you will be privy to these three, and there are ways you can calculate or change them from one form to the other. Let's look at the decimal and the binary number system. So when we talk about decimal system, it is the number system commonly used by humans in their daily lives. It has 10 symbols. So here we are not talking basically about numbers, but we are talking about codes and symbol. You know, programming is about coding or code. Good. So anything we talk about here is symbol or code. Don't see it as a number, but as a code that is used in programming. So when we talk about decimal system, it's also called base 10, meaning it has 10 symbols. 10 symbols means it begins with 0 and ends with 9, meaning it has 10 symbols. The first symbol is 0, second symbol is 1, 2, 3, and ends on 9. So you can see the symbol 10 is not included. That is the decimal system. Mostly the symbols are equal to the base number. So if it is base 10, we have 10 symbols, but the number itself wouldn't be included. So we always begin with 0 for decimal system and ends on 9. This decimal system is what we use in our daily life for counting, for monetary value checking, for writing algorithm, for so many things. We use them in our daily life. They are the normal numbers we use. So from 0 to 9. Programmers think and calculate in decimal system, writing algorithms and so on. Algorithm is a step-by-step approach that is used to solve a problem or solve a task. We'll look at that some other time. So it's also called the base 10 numeral system, and it has 10 symbols. So out of this 10 symbol we can form any number, right? We can form 10 out of this number. We can form 11. We can form 20. We can form 50. Just mention the number. We can form all these numbers out of just this 10 symbols, and that is the decimal system or the base 10 numeral. Let's quickly look at the binary system. So the binary system is also the language that the computer understands, or the binary system is the natural language of the computer. It has two symbols. Okay, so just like I said, the base name will tell us the number of symbols. It has just two symbols, that is the 0 and 1. Now, do you remember, or do you always see this symbol, this thing? Yes, this thing you see, this bar you see is 1. This bar you see is 1. Then what you see around it is 0. So this is binary number system. That is the language in ones and 0, or the language that has ones and 0. So on your setup, on your electronic device, if you see 1, it means on, 0 means off. That is where we get the switch from, and that is the binary system. This system is used for data storage, so we can have the 2 kilobytes, the 1 megabyte, the 1 terabyte, the 1 petabyte, 1024 megabytes giving us 1 gigabyte, and so on and so forth. They are also used for machine code, the machine code. Now, how do we convert or calculate from one system? We are starting with the decimal. If I have a decimal number, how do I change it from decimal number to binary? These are the steps. Now, step 1, you divide the decimal numeral by 2 repeatedly till it becomes non-divisible. You read your results using the remainders in a reverse form. So anytime you are given a number in base 10, to change it to binary, you divide it by 2 till you get a number which cannot be divided again. Then you read your answer in the reverse form, that is from the top to down. Let's look at how we do that. So number 1, we have to convert base 10, which is a decimal numeral. Okay, so mostly with the decimal numeral, you see just the number coming, or you see 10 attached to it, something like this. So this can be read as 10 base 10, or just 10. So this way, 10 with a subscript 10 attached to it. All right, good. So you can call this 10 base 10 or just 10. So convert 10 to binary. Convert 10 to binary. So how do you do this? Draw a table with 3 columns. So column 1, column 2, column 3. The first column will take the base 2. The second column will take your number, which is the number you are changing, 10. Then the last column will take your remainder. Alright, so divide 10 by 2. 10 by 2 is going to give you 5. Would there be a remainder? No, so that is 0. Divide 5 by 2. 5 by 2 will give you 2, remainder 1. 2 divided by 2 will give us 1, remainder 0. 1 divided by 2 will not be possible. It's going to give us half. So in this case, we take it as 0, since the division wouldn't be too smooth to work with. We put 0 there, then repeat the last number. The number that came before 0 was 1, so you repeat the same one at the last point. You read your answer in the reverse form from down to top. So your answer will now be 1 0 1 0 base 2. 1 0 1 0 base 2. Let's look at the second one. We have to convert 13 base 10 to binary. So the same with 3 columns, a table. First one will take your base 2. Second one will take your number, your decimal number, which is 13. You see here is 13 base 10. Could be just 13 or 13 base 10. That will take the second column. And the last one is your remainder. 13 divided by 2 is 6, remainder 1. 6 divided by 2 is 3, remainder 0. In other words, 6 to 12, remainder 1. 2, 3, 6, remainder 0. 2 will go into 3 one time, remainder 1. Because 2, 1 is 2, remainder 1. 2 will go into 1, it's not possible, so 0. Then you repeat the last number there. Here, you read in the reverse form. So your answer will be 1 1 0 1 base 2. 1 1 0 1 base 2. So I want you to try this for me as an assignment, okay? And then leave your answer in the comment section. Now we'll look at converting binary to decimal in the next chapter or the next episode. So thank you for watching. This is your humble tutor, Sir Henry, and we looked at converting decimal to binary numerals in the concept of programming. Thank you for watching and have a nice day.